These are the quantities which is related to this object, which is this pencil. But by just looking at this number, can you guess what are they telling me about? Yes, can you guess what are they telling me about? You can obviously know, okay, something is 5, something is 20, something is 10, something is 6. What is that something? What are these physical properties that I am reading about? So can you tell what are these quantities? What information am I going to get? Yes. You have to answer very quickly. Yes or no. You have to just answer in N or Y. So just N or Y. So can I tell which one is volume, which one is length, which one is mass? Right now I'll do the other thing. What I'll do is I'll put gram here. Let's put centimeter cube here, centimeter here, and degree Celsius here. So obviously 6 degrees we'll not have right now. So let's write the ambient temperature, which is 25, right? Now, can you tell me what is 5 gram? Now we have an idea. What are they telling me about? Which physical quantities am I measuring? So here now, obviously, by looking at gram, you can say what it is telling me. Just quickly answer this. Yes, we have the mass, we have the weight of this pencil. Here we are looking at the volume. Here I am looking at the length. And yes, this quantity is telling me about the temperature of this substance, which is this pencil. So yes, these units, they mean something, and they are going to tell me about the properties of this substance, which may be a mass, which may be a volume, which may be length, or which may be a temperature, right? So now quickly let's see what are the physical quantities that we have to know, and what are the methods, or what are the scale that we will be using, or what are the system, what are the basic units that we have to see or we must know before going into the details of the subject. So these things you will be learning in physics also and here also. So the system that we will be using for measuring this quantity is the International System of Units. International System of Units, which is known as SI system, right? Which is known as SI system. Now quickly type Y if you know about the units that are there in this system. So basically here we have 7 basic units. Now the very general question is, why am I learning about this particular system? So the thing is, we have to learn about this system so that we learn what are the units that are used universally by all the people. So that if somebody sitting somewhere in the other country gives you this value, which is 5 gram, now sitting here and reading this, you understand the information as given to you. There is no confusion because we have adopted a single system by which we will be telling about the different measurements that we are taking, so that there is no confusion, right? So we have to adopt a universal system which is accepted by all. It's not like that we are using a different system in India and somebody sitting in US is using a different system. In that way, the communication or the understanding of the information will become very, very difficult. For that, again, they will have to learn about the system we are using, and we have to learn about the system they are using. So that's why there is a need of a common system which is used for writing the measurements or for measuring the physical properties. So yes. So what do we have? What are the 7 base units? So we have length, mass, time, temperature. Yes, what else we have? We have length, mass, time, temperature, electric current, amount of substance. So we have amount of substance. So now here, one more is left. What is that? Luminous intensity, which you will not be using that much in chemistry, right? Maybe you will see it somewhere in physics. So yes, these are the quantities that we will be measuring, which is the length, mass, time, temperature, electric current, amount of substance, and luminous intensity. So what are the symbols for these quantities? So I hope you know. Here we will write small l, mass is m, time is t, temperature is capital T, electric current is, we are using the unit which is ampere. So we will be using I for it, right? Ampere will be a unit that we will be using for it. Amount of substance is, we are using mole for it, and luminous intensity is also denoted by IV. Now, what are the symbols? So this is not that important for us. The thing that is important for us is what are the units. So quickly write the units for the same if you know. So one by one, you have to tell what is the unit for length. Yes, what's the unit for length? Okay, candela is the unit for luminous intensity, right? So we have got candela, which is CD. What else? Whatever you will answer, I'll write it. So the more, so your speed has to match so that we can learn more new things. So length is meter, which is small m. Mass is kg. Time is second. Temperature is Kelvin. Electric current is ampere. Amount of substance is mole, which is denoted by N. So this is mole. So we'll write meter and we'll write the complete name on the other side. So this is candela. So the number of moles is denoted by small m, which we will be learning about in the coming sessions. That is, we learn about the moles. Then we have length, which is measured in meters. So the standard unit for length is meter. So SI unit for length is meter. Now everything we will be learning in the respect of meter. And for mass, it is kilogram. For time, it is second. For temperature, it is Kelvin. So there are few units which you already know. Current is ampere. Amount of substance is mole. And this is candela. Here, this is second. This is kilogram. And this is meter. Obviously, all of these things will be there in your textbook. So the only thing that you have to focus on is understanding these and just knowing what is the unit for length, what is the unit for temperature, and basically here first we are starting with the standard units, right? Now, slowly we will see what are the other units that we will be practically using in this subject, right? So before that, we will see some prefixes. Prefix and what is the value, right? So let's suppose I have pico, right? Then that is equals to 10 raised to the power minus 12. So how do I write? So 1 picometer is equals to 10 raised to the power minus 12 meter. So here I'll be telling you the other units or the other prefixes which will be commonly used in chemistry. There are other prefixes also, but you'll not be using any of them in the chemistry. So I'll be writing the prefixes that we will be using commonly in chemistry. So the one that you will be using is pico when we will be learning about the solid state, in which we will be learning about the atoms, their radius, and other things. So first one is pico. Then we have nano. So wherever you see nano, then the value is 10 raised to the power minus 9. So you have to write the same thing in the similar fashion. 1 nanometer, if I say for the length, nanometer is equals to minus 9 meter. And I hope then you can write, if I ask you what will be the value of 1 meter in picometer, so it will be 10 raised to the power 12 picometer. So I hope did we do that? So we just simply took it here, and then when the negative power goes up, then it will become positive. So we have pico, nano, micro, milli, centi, deci, and what else is important for us is kilo. So kilo is 10 raised to the power 3. Deci is 10 raised to the power minus 1. Centi is 10 raised to the power minus 2. Milli is 10 raised to the power minus 3. Micro is 10 raised to the power minus 6. Now, what are the symbols for these? So for pico, I'll be writing P. For nano, I'll be writing N. For micro, it will be denoted by nu, the same symbol that we are using for the refractive index. Milli, simply M. Centi is C. Deci is D. And kilo, you know, that is K. So whether you put kilometer, kilogram, so these are the values which you should learn. These are important. These are important for you to know, because these things will help you in the conversions. So the only confusion that will be there is whether I put positive 12 or whether I put the negative 12. So whenever you are going from the unit which is larger in value and you're going to a unit which is smaller in value, then obviously always the power will be in positive. For example, as you can relate it with meter and centimeter. So 1 meter will be equals to 10 raised to the power 2 centimeter. Now opposite of it, how I'll write? I'll write 1 centimeter, and as you can see here, it is 10 raised to the power minus 2 meter. So I am going from the smaller unit to a larger unit. So whenever I am going from a smaller unit to a larger unit, obviously it will be a smaller value. So the power will be in negative. So the only thing that may confuse you is the power. Maybe you'll remember the value, but the only thing that will happen is whether the power was positive or was it negative. So whenever you are going from a smaller unit to a larger unit, then the power will be negative. And if you are going from the larger unit to the smaller unit, then the power will be positive. So now I hope you have all noted these down. With this, we'll move to the different physical quantities, and the important part for you, the skill that you should learn, is how do we convert one unit to the other unit. So here we will start with the mass and the weight. So the first physical quantity that we will learn about is mass and weight. And I hope you all know what's the difference between the mass and the weight. So I'll quickly revise this and then we will move ahead with the conversion. So mass is basically the amount of substance. It is the amount of substance. Whereas the weight is the force exerted by gravity. Force exerted by gravity. And here your weight will be equals to mass into gravity. And that's the reason that your weight on earth, it will be different than the weight that you will have on moon. And what's the difference? The weight on the moon will be 1/6 of the weight that you have on the earth. So why the weight has changed? The weight has changed because the gravity is different on earth and on the moon. So I hope now you know what is the difference between the mass and the weight. Now, as I have told you, the standard unit, the SI unit for this is, the SI unit of mass is kg. Now, here the important part is that you should know the conversions. So, this everyone knows that 1 kg is equals to 1000 grams, which can be written as 10 raised to the power 3 gram. Similarly, 1 gram is equals to 1000 milligram. What is mg? Mg is milligram. Gram. So then it becomes 10 raised to the power 3 mg. Right? So that's how you have to do the conversions. Now, your homework is you have to do the relationship between kg and milligram. What's the homework? The homework is, or else if you can quickly tell me in the chat, what is 1 kg in mg? So what should be the power of 10 here? Yes, I am waiting for your answer. And by then we'll move on to the next physical quantity. Yes, yes, it will be 6. It will be 6. So 1 kg will be equals to 10 raised to the power 6 mg. Now, do you understand how did we get that? How did we get that? So as you know that 1 kg is equals to 1000 gram and 1 gram is equals to 1000 mg. So here what will happen is, yes, how we will get it? So if how did we get it? If that is that you know, then we'll move to the next topic, which is now we will learn about the volume. Is it 10 raised to the power 6 mg? This is our question. So if you know how did you do it, then you will get the correct answer. I am not getting any other answers. Just Bhavna has answered is that is 6. So yes, we will leave it for tomorrow and we'll see whether you get it right or not. Now let's move on to the volume. So now, as you may know, what is volume? Volume is the amount of space that will be occupied by any object. And here, mostly we will use the word substance, right? In chemistry, we'll be dealing with the chemicals, we'll be dealing with different substances. So yes, how we will write it? It is the amount of space. It is the amount of space occupied by any substance, right? Now, what will be its unit? So its unit is the cube of length. Now, what is the unit for length? It is meter, so it will be meter cube. Now, let's suppose if I take a cube whose dimension is 1 decimeter by 1 decimeter by 1 decimeter, right? If I take a cube whose dimension is 1 decimeter, length, breadth, and height is 1 decimeter by 1 decimeter by 1 decimeter, then the amount of substance that will come in this cube will be equals to 1 liter. That's how we define 1 liter. So if I take a cube whose dimension is 1 decimeter by 1 decimeter by 1 decimeter, then the amount of substance that will come in this cube will be 1 liter. So how can I write this? I can write this as 1 liter is equals to 1 decimeter cube. This is the same, you have to remember this in the same sequence, because as you will move ahead, you would need these conversions. You would require to convert from one unit to the other unit, especially for the volume. Why I'm emphasizing on volume? Because then when we are dealing with the solution, we will be talking about the volume again and again. Now the difficulty will be when you're solving the numerical is you would be given the different units, and the formula that you might have learned will be in the different unit. So the conversion there plays a crucial role to get a right answer. So listen to this very carefully. I am saying it again because in the exam we usually get confused when we are converting these units for volume. Now, what I have said is, I'll repeat it again, that if I take a cube whose dimension is 1 decimeter by 1 decimeter by 1 decimeter, then whatever is the amount of substance that will come in this cube, that will be equals to 1 liter. Now, on the same hand, if I take a cube whose dimension is 1 centimeter by 1 centimeter by 1 centimeter, then the amount of substance that will come in this particular cube, so let's name them. So this is A and this is B. So the amount of substance that will come in this cube will be 1 ml. So I'll write it as 1 centimeter cube. So I'll write it as 1 centimeter cube. Now, here, what we can see is 1 liter is equals to 1 decimeter cube and 1 ml is equals to 1 centimeter cube. Now, you have to tell me what's the relationship between centimeter and decimeter. Yes, quickly you have to tell me in the chat what's the relation between the centimeter and decimeter. Yes. So, so you have to answer in the chat. What's the relation between centimeter and decimeter? So if I write here, 1 decimeter is equals to how many centimeter? So you have to, nobody is answering. You have to be quick with this. So just now we did it. So try to answer this by looking at this table, right? We just did centi and decimeter. So you should be able to do all these things by yourself if you know the basic informations also. So you have to develop that skill from where you can interconnect the things. So from here, what we can write is, yes, 1 centimeter is equals to 1 by 10 decimeter. Yes, Bhavna has answered this. So how can I write the decimeter? I can write 10. So how you can remember it? Decimal. Decimal is related to 10, right? So 1 decimeter is equals to 10 centimeter, right? So now what I can write is 1 decimeter cube will be equals to 1000 centimeter cube. What I can write? 1 decimeter cube will be equals to 1000 centimeter cube. So now you know what is 1 liter. 1 liter is equals to 10 raised to the power 3 centimeter cube. How did I write 10 raised to the power 3? So we have 3 zeros here, right? So we will be writing 10 raised to the power 3 centimeter cube. Now, do you know what's the relationship between liter and ml? That we all know, that 1 liter is equals to 1000 ml. 1 liter is equals to 1000 ml. Now, I hope you can do all the conversions, whether they are asking you to go from centimeter cube to decimeter cube, or from decimeter cube to centimeter cube, from ml to liter, or from decimeter cube to ml. So what we have learned is that your 1 liter is 1 decimeter cube and 1 ml is 1 centimeter cube. And the best way to remember this is, if I take a cube whose dimension is 1 decimeter by 1 decimeter by 1 decimeter, then in that cube I can fill a liquid which will have the volume of 1 liter. And in the similar way, if I take the cube which is having the dimension of 1 centimeter by 1 centimeter by 1 centimeter, then in that the amount of substance that will come in this particular cube is 1 ml. Now, once I know what is 1 liter and once I know what is 1 ml, then obviously we can do the conversions, because this we all know that 1 liter is equals to 1000 ml. Now, if 1 liter is 1000 ml, then 1000 ml will be equals to 1000 centimeter cube. So that's how you have to do the conversions. Now, the other thing here I want to tell you is, the only thing that will confuse you in the units is what is decimeter cube. So from here onwards, you should know that 1 decimeter cube is liter. Decimeter cube is liter. Again and again I am telling you, because when you see the units, we get confused, because usually there the density, it will be given in terms of gram per centimeter cube, or you may be given as kg decimeter cube, and that's where we get confused, like what is decimeter cube. So decimeter cube is basically 1 liter. So I hope this is clear to you. So if this thing is clear, just type Y and we'll move ahead. So now, after looking at the volume, the next thing that we have to see is density. So density, as you may know, is, so nobody is replying. So have you understood this volume and the conversion of units? So you have to remember it in the same way, that is in the form of the cube. So if you remember the cubes, you will remember the conversion, and also you will remember the decimeter cube is 1 liter. Yes. So you have to quickly answer this, whether you have understood this. Then we'll move on to the next topic, which is density. So I am waiting for your reply, and then yes, we will move on. So I think there are many students, but only few are responding in the chat. So everyone has to respond. Everyone has to be active in the class. Yes. So yes, now these things should not confuse you further when you are reading the chapters which is solution, or in this chapter also, that is in basic concepts, we learn about molality, and there we will be using these units. So these are the units for volume. Now, as you know that density is equals to, so usually density is denoted by symbol rho, right? So density is equals to mass upon volume. So now if I write the SI units, Yes. So density is equals to mass upon volume. Hmm. So the unit, SI unit for mass is kg and volume is meter cube. So what we will say that in the SI unit, what's the unit for density? Kg per meter cube. Now here is your homework that you have to write, or else you can do it here or you can do it right now. That is because why we are doing the conversions here, because when you are dealing with chemistry in and you are doing the experiments, then you will never be taking the volumes in liter, right? Liter is a very large quantity. What you will be dealing with is ml. Here you will take 100 ml, 10 ml, 50 ml, 40 ml. There you will see very few numericals which will be where we will be dealing in liters. Obviously, numericals are based on the experiments which are possible in the reality. They are not some numericals which are just made out of imagination, right? So obviously, the numericals, whatever you will phase, they will be related to however the experiments are conducted. So whenever we are dealing with the chemicals, they will usually be in smaller quantities. So there you should know what are the smaller units for volume, and similarly there we will be looking at the substances. So there we will be dealing with the density. So for density also, you will see that it will not be given in kg meter cube. Usually, it will be given in gram per ml, or it will be said written as gram per centimeter cube. So now what you have to do is, your homework is that you have to convert kg meter cube into gram per centimeter cube, or what we say gram per ml. Now I hope now this thing is clear to you that whether I write centimeter cube or whether I write ml, both are the same things. And the last one that we have to learn is temperature. So the last thing that we have to learn about is temperature. So the SI unit for temperature is, which you have to remember throughout the chemistry, is Kelvin. And the other important thing is that obviously we have to know all the three scales that we are using for measuring the temperature. Is we are using the Celsius scale, we are using the Fahrenheit scale, and we are using the Kelvin scale, right? So these are the three scales that we are using for measuring the temperature, and the SI unit is Kelvin. So this one you will be seeing a lot in all the chapters because this is the SI unit. And whereas the thermometers that we are using, most of the times the temperature there is in degree Celsius. So there you have in the degree Celsius. And in numericals also, you will be given the temperature mostly, not mostly, in Fahrenheit. You'll never see the temperature in Fahrenheit. In all of the numericals, the temperature will be in degree Celsius. So how do I go from degree Celsius to Kelvin? Because this is what we have to convert to. So whenever you are given the temperature in degree Celsius, then to that temperature what I have to add, I have to add 273, and that's how I'll get the temperature in Kelvin. For example, let's suppose if I have 27 degrees Celsius. So if I add 273 to 27, then I'll have 300 Kelvin. Now, let's suppose you have to do the opposite. You have to go from Kelvin to Celsius. Then obviously what you have to do is you have to take the Kelvin temperature and you have to subtract 273 from it. Now, the other one which you may not require a lot is that is the conversion from Fahrenheit to degree Celsius. You have to do from degree Celsius to Fahrenheit. So what we have to do is 9 by 5, and whatever you have temperature in degree Celsius, and to that we will add 32. So that's how we will convert from degree Celsius to Fahrenheit. Now, the other thing is, when you learn so much, the probability is that you may forget whether it was 9 by 5 or 5 by 9. So, how you can remember is 5, right? 5959. Like that, you can repeat. So, it will stuck in your mind. So, 9, 5, it will rhyme. So, in numerator, we will have 9 and in denominator, we will have 5. So 9 by 5 degrees Celsius and then we will add 32. So these are the scales for measuring the temperature. Whereas the degree Celsius, it will be scaled from 0 to 100 and 0 and 100. These are the boiling point. This is the boiling point for water, 100 degrees Celsius and the freezing point of water. So 0 degrees Celsius is freezing point and 100 degrees Celsius is the boiling point. Whereas if I talk about Fahrenheit, then it is from 32 to 212. So that's why we are adding 32 here. So these are the things. So here in these classes, I am telling you from the perspective that the things which are important from the exam point of view or from where you will be getting the numericals. So yes, these are some of the physical quantities which we will be measuring, and these are important for us to know. And the very important part is the conversion of units. I am again and again emphasizing that the conversion of unit is very important. Theory is fine. Nobody is going to ask you about the theory, like what is density, what is volume. What will you have to take away from here is how do we convert one unit to the other unit. So yes, now, so is the so I hope this is clear to you all. So just quickly type yes and then I'll take the doubts. So by the time you are typing, so we'll see what are all the things we learned. So today we learned about the physical quantities, right? And now I'll tell you what are we going to learn in the next class. So we will be learning about the laws of chemical combination. Yes. Where are other students? So all have to participate. So yes, is things clear to everyone? So this is what we have learned. Yes. So again, we'll do a quick recall tomorrow, and then we will start with the law of chemical combination. In that, what are we going to learn is we will learn about the law of conservation of mass. We will learn about law of constant proportion, law of multiple proportion, Gay-Lussac's law, and the Avogadro law. So these are the laws that we will learn about, and then we will move on to the main topics, which is we will learn about the molecular empirical formula, we will learn about the moles, and we will learn about the limiting reagent, we will learn about the concentration terms. So these are the four topics that we have to learn further to understand some of the basic things about chemistry. Until now we have learned about matter. How do we classify the matter? What is the system that is used for measuring, for the measurement? And this we learned about the international system of unit, which is the SI system. And in that we saw what are the standard unit and what are the 7 basic units, which were these, which is length, mass, temperature, amount of substance, and luminous intensity. So if there are any questions, you can ask in the chat box. and I'll answer those. Yes, if there are any questions from what we have learned today, you can ask those questions. So these are the top, this is the topic that we learned about in the today's class. That is the international system of unit when and what are the seven fundamental units. And then we saw the what is mass, weight, volume, density, and the different scales of temperature. Yes. Is there any doubt? So I hope that everything is clear to you. Okay, so here we have some questions, which is, so I'm not, so we'll take this question, which is asked by Bhavna. So Bhavna, exactly, I'm not able to understand. This, that is, you are asking is the reference to refractive index, then how and will be amount of substance. So you can tell your exact queries to ma'am and then I'll answer this. So here now the question is not that clear because I think you are just typing it in the parts. So is there any other queries you have related to today's session? I'll take that, and after that we'll end the session. Okay. What's the relationship between decimeter and centimeter? So let's suppose I have this pen, right? I'll say that the length is 1 decimeter, right? Now, if I take 1 centimeter parts into it, so if I'll break into centimeter, right? So how many parts of centimeter I'll get from this pencil? I'll get 10 parts. What I'll get if I'll break this pencil, then I'll get the 10 parts of 1 centimeter each in this. That is what it means. That 1 decimeter is equals to 10 centimeter. If I take any rod which is the length of 1 decimeter, and then if I want to break this rod in centimeters, then I'll get the 10 parts. I'll get the 10 pieces, which will be of the 1 centimeter each. Or in the other way, what you can say, if I take 10 parts, if I take 10 pieces of 1 centimeter each and I join them, then I'll get a rod which will be of 1 decimeter, right? So that's how you can do. Or else if you forget everything and if you remember the prefixes and the quantity, from there also you can find the relationship. So the amount of substance is moles, and in chemistry, the moles is written as N. There I said mu, not new. Mu. Mu is for the refractive index, which you will learn in physics also. So I didn't say n, it was mu. Mu is the symbol that we will be using for the refractive index also. And n is the symbol that will be used for denoting the number of moles. So then we'll see the formulas in terms of n. So wherever in chemistry from now you'll see n, then that means it is talking about the number of moles. So n is for the number of moles. It was new, right? For micro, right? New. We'll write new for micro. So let's suppose I write micrometer, right? So the symbol is new. So I hope with this I have answered all your questions. And if there are any other questions, you can ask ma'am in the group. So then I'll see you all in the next class. Till then, keep learning and keep asking questions. Yes, ma'am.
Yes, ma'am. Thank you, ma'am.
Okay. Okay, ma'am.
Yes, ma'am. Yes, students. Now I would like to invite Arun sir to continue the session.
Thank you so much, ma'am.
Thank you, sir.
Yeah, all right. Hello, students. Yeah, good evening, Gayatri. Good evening, Jyoti. Hello, Pravalika. So, how are you all doing? Students, in exercise ఇచ్చాను ఒకటి చిన్న exercise ఇచ్చాను 10 minutes exercise. Have you done that? Did you all draw the circle and have you all derived all the trigonometric functions from the circle? Have you done that yesterday? It's very important that you do 10 minutes exercise every night before you sleep, students. I'll give you just 10 minutes exercise every day. Happy evening, Bhavna. Okay, Gayatri has done. Others, have you done? It's very important that you do 10 minutes exercise every day, students, before you sleep. Apart from the assignment or any homework is given, this 10-minute exercise is very important. Especially till the mechanics is completed, is very important. Basic maths and mechanics involves a lot of visualization. All right, have you all done that? Students, please answer so that I can get started. Gayatri says yes, sir. Others, have you all done? If you haven't done, please do it from today. Say yes or no. You can say either say yes or no. If you haven't done, please say no. Exercise ichano that you draw the circle and draw the tangent, cotangent, sine, cos, cosecant, secant. Have you done that? Students, it's very important that you interact. That's okay if you have not done it yesterday, but from today, please do it. So please respond whether you have done it or not. No is also fine. Okay, okay. Bhavana says no. Ashita says no. Okay, some difficulty you are facing. All right. Deepika says no. All right. Okay, that's okay. And others, be honest and be sincere, students. That's very important. See, I will know how to conduct the class if you have done that or not. All right. I can continue the class depending on whether or not you have done the 10-minute exercise. All right. So the students have been facing little. Okay, Bhavana says facing difficulty in that. All right. All right. And also I've given homework of tan of pi plus x, tan of pi minus x, tan of pi by 2 plus x, tan of pi by 2 minus x. Have you tried that? Students were answering in the class itself. That was very impressive. Adichya Sara, tan of pi plus x, pi minus x. Okay, Gayatri says yes. Good, good, Gayatri. Okay, let's get to that. So let's quickly. This is a unit circle. I've got a tangent here. a cotangent here. This is my radius. This is my radial line. This intersects the cotangent here, intersects the tangent here. This component, the horizontal component is nothing but the cos. Vertical component is sine. This cot, let's see where are secant and cosecant. I draw a tangent here. This intersects the horizontal axis at this point. This is secant x. And this intersects the vertical axis at this point. This is cosecant x. Is this clear to everyone? All right. I hope it's clear now. Is it clear now? Ma'am, is the strain clear, ma'am? Could you please mention? All right. Students, I hope this is clear now. You're able to see the screen clearly. All right. Good. Yeah, good. That's it. Good. Yeah, that's it. Good. All right. So this is the trigonometric ratios functions we had on this circle. Now, let us see if I this from 0 to pi by 2, this is called the first quadrant. Pi by 2 to pi, this is called second quadrant. Pi to 3 pi by 2 is called third quadrant. 3 pi by 2 to 2 pi is fourth quadrant. All right. So first, second, third, and fourth. Now let us see what are the functions which are positive and negative in these respective quadrants. Okay. Oh, excuse me, ma'am. Chandrika, ma'am.
Yes, sir.
Ma'am, is the board clear?
Yes, sir.
Is
Yes,
it
sir. It
visible,
is
ma'am?
clear. Yes, sir.
All right, ma'am. Thank you. Bhavana, please check at your end. If at all you have some issues in this, you please switch to YouTube channel. Bhavana, you please switch to YouTube channel if at all you're facing any issues in the network and the connectivity at your end. Because others are facing it fine, feeling it fine. All right. Okay. Just fill this box with plus or minus depending on the value is positive or negative. Is cos positive in the first quadrant between 0 to pi by 2? Is the cos positive? Is the shadow on the right side of the x-axis or horizontal axis? Is it positive or negative? Cos is positive or negative between 0 to pi by 2. Is it positive or negative? Please quickly type in the chat box. We need to cover a lot. Unless you interact, I will not know whether you are able to understand or not. All right, good. Right, good, good. Gayatri, positive. All right, good. So positive is the response I'm getting. Good. Ashrita says positive. And who else? Yes, positive. Positive. No, one of you says negative. So it is not negative. Look at this. The projection of this radius on the x-axis, on the horizontal axis, is towards right between 0 to pi by 2. So that's positive. So cos is positive. Cos x is positive in the first quadrant. Sine is also positive. Tan, how about tan? When this is between 0 to pi by 2, my intersection of this infinite radial line is above the horizontal axis. So this is also positive. How about secant? I draw a tangent line between 0 to pi by 2. This goes from here to infinity. So at 0 it is 1. At pi by 2 is not defined. So it goes from 0 to infinity. It's positive. How about cosecant? Cosecant also, it goes from infinity to 1. That is also positive. How about cot? When it goes from 0 to pi by 2, it comes from infinity to 0. That is also positive. So in the first quadrant, all are positive. All right. Okay, I'll do one thing, students. I'll do it on the system. I'll do it on the screen instead of, because that's being blurred to some students. I'll do it on the screen.
Is there any issue, sir?
Like, is it visible clearly, ma'am? Is it clear? Is the screen clear,
Yes,
ma'am?
sir. Clear, yes, sir.
All right. Hmm.
Please wait for a few seconds, students. There is some technical issue. Yes, sir. Now you can share the screen, sir.
All right. Hope it's clear, ma'am. All right. So let's complete the table. In the second quadrant, when it goes from pi by 2 to pi, when x goes from pi by 2 to pi, what is sign? Is sign positive? Look at the circle and say, decide whether it's positive or not. When my x is somewhere here, radius is somewhere here, this is x. Sign is definitely positive. And because sign is positive, I write it positive over here. Cos is negative. Tan, I extend this line. Tan is negative. Secant, I draw a tangent. Secant is negative because secant is 1 by cos. I can write that as negative. Cosecant, sine is positive. Cosecant is positive. Cot is again negative. All right. Now in the third quadrant, when the radius vector comes somewhere here, yes, Gayatri, that's absolutely right. Good. In the third quadrant, think and tell me, Gayatri, and others as well. Yes, Gayatri, that's absolutely right in second quadrant. In the third quadrant, I've got sine as negative, cos as negative, tan is positive, secant is negative, cosecant is negative, cot is positive. In the fourth quadrant, sine is negative, cos is positive, yes, excellent, excellent, good students. All right, in the fourth quadrant, students, think and tell me in the fourth quadrant, I'll fill the box, and there's a shortcut actually, which is not used much, but still I'll tell you. In the fourth quadrant, I've got tan is negative, secant positive, cosecant negative, cot negative. There's a mnemonic, a shortcut to remember this table, and that goes like this. They say all are positive here, whereas S, which is sine and cosecant, are positive here. So they say S is positive silver, tan and cot are positive here. They call it T, and cos and secant are positive here. They name it as cups. So A, S, T, and C. And they say all silver tea cups. Just to remember this table in a mnemonic form, we say all silver tea cups. All are positive here. Yes, Ashrita, that's exactly right. Yes, Bhavana, excellent, excellent. Ashrita, excellent. Very good. All silver tea cups. Yes, but we don't use this mnemonic, students. This shortcut is never used in physics. We only go by either logic or some geometry or some projection. Yes, that's another mnemonic here. All school to college. That's excellent. There is one more. There's one more there. Think about it. They say all school to college. All school to college is another mnemonic where C stands for cos, T stands for tan, T stands for tan, S stands for sine, and A stands for all. That's good. But mnemonics we don't use, students. In bio, you use a lot of mnemonics. You will not remember so many mnemonics in the such cases. In physics, you have got only one mnemonic, one such shortcut, which we don't use at all. Yes, Gayatri, that's another one. Yes, good. That's the one. All students take coffee. So even though they don't, but we still say all students take coffee. That's another one. Yes, good. All right. But we don't use this mnemonic at all. We hardly use this mnemonic, this memory shortcut. All right. Shortcuts are dangerous. Unless you know the logic behind it, they are very dangerous. All right. Now let's get back to the homework which I gave you. Tan of 5 plus x, pi minus x, pi by 2 plus x, and pi by 2 minus x. Have you all done it? If you haven't done it, I'll do one. I'll leave the rest to you. Then we'll go for graphs, because we need to complete graphs as well today. If you have done that transformations, please type in the chat box your answers, what your answers are. Answers type change in chat box low. What is tan of 5 minus x, tan of 5 plus x? Tan of 5 by 2 plus x, tan of 5 by 2 minus x. All right. Have you all tried that? Can anyone tell me tan of 5 by 2 minus x? Excellent, Gayatri. Excellent. I don't know how you have derived it, but if you have derived from memory, telling from memory, that's also good. But if you can do it through geometry, that's even better. All right. Geometry is all the more important than memory. That's absolutely right. How about pi by 2 plus x? Students, please try to think. Gayatri has already told the answer. That's absolutely right. Okay, let me just do one so that, or if you want, you can unmute yourself and speak. If you have difficulty in typing that pi and everything, you can unmute yourself and speak. Yes, Gayatri, that's excellent. Pi by 2 minus plus x is okay. That's great. Okay. Bhavana says minus tan x, but that's for what? Is it for pi plus x, pi minus x, pi by 2 plus x, pi by 2 minus x? You write pi as pi. All right, that would be sufficient. You don't have to write the Greek letter pi. Good, Bhavana. Good, Gayatri. But Gayatri, can you do me a favor? Can you just draw that diagram and then show the pic to me with the camera? Good, Bhavana. Excellent. That's excellent. That's absolutely right. Gayatri, can you draw that diagram for pi by 2 minus x or pi by 2 plus x, whichever you want to show on the diagram on a circular geometry, and show that on the screen so that everyone can see that. I must really appreciate Gayatri and Bhavana. Okay, Bhavana, I'll tell you how to do it. All right, Gayatri. All right. See, students, the whole idea behind this session is to introduce you to new methods. All right. If you know this from memory, that's great. But there are going to be new ways of thinking which you have to adopt. Physics లో చాలా కొత్త వేస్ ఉంటాయి థింకింగ్ కి. గ్రాఫ్స్ కూడా మీకు తెలిసే ఉంటాయి, ఫంక్షన్స్ కూడా తెలిసే ఉంటాయి. కానీ new ways of thinking are introduced in intermediate, especially for IIT Advanced and Neet. We need new ways of thinking. So that is why I'm introducing such things. All right. It is very important that you understand, try to think in those direction which are new to you now. కొత్త మెథడ్స్ లో ఆలోచించగలగాలి మీరు. All right. So that's why that 10-minute exercise I told you. Have you all done that? If you were to do that, you would have not faced that difficulty. Yeah, I appreciate the ones who have done. And I'm not here to discourage anyone. But because it's a less in number, we should do it together and we should do it in a better way, more interactive. All right, I'll just clarify this Bhavana's doubt, then we'll go for graphs. See, look at this. I've got a circle. And let's say this is X. I'm talking about tan, so I'll just draw the tangent here. I'm not bothered about the projections. I extend this line. This intersects over here. Now this is my tan, right? Now what is tan of pi plus X? Where is the arrow where is the radius when it is pi plus X? It is in this direction. And this is pi. The total angle is pi plus X. Now look at the tan of this value. What I do, I extend this radial line. This again intersects at the same point. As this radius was intersecting, this radial line was intersecting at this point. When I rotate this by pi, my radial line is again intersecting with the same point. So my tan has not changed at all. So tan of X, this intersection is same as intersection of pi plus X. So tan of pi plus X is equal to tan X. All right, that way. Students, you will have to remember so many things in maths, physics and chemistry. So it's very difficult to, if you don't know the logic behind it, it's going to be very risky. You have to adopt a new ways of thinking. New ways of thinking, adopt cheyali meer ippudu. All right, and it's going to be really rigorous. It is just the beginning. All right, next week is going to be rigorous. Calculus start అయితే చాలా rigorous ఉంటుంది. Thinking చాలా develop కావాలి. Yeah, sure, Bhavna, I'll do that. All right. So I think students have not got the thought process yet. The intention behind it, the thing is, we need to adopt to new style of thinking, new ways of thinking, new levels of thinking. Next week is going to be really, really high level of thinking. All right. For that, I'm preparing you with this. So don't think that you will have same level of thinking as you had in 10th or intermediate board course of thinking. But we are targeting IIT, JEE, NEET and Olympiads, advanced, beyond advanced. So level of thinking required is very high. Our level of thinking kosam memo train chestunnamo. So please understand that. I'm repeating this again and again. Don't get irritated by listening to this again and again, but try to understand the point behind it, that we need to raise our levels of thinking to a next level, to a higher level, to a very higher level actually. All right. Let me just complete this pi plus pi minus X now. I've got X. This is pi minus X. So tan of X is this dot. And this is also X in magnitude. Tan of pi minus X is this dot. Now look at this. This dot is same at the same distance from this dot as this center origin. Because this is also X, this triangle and this triangle are congruent. This length is equal to this length, but negative side. So tan of pi minus X is equal to minus tan X. Is this clear to everyone? Students, you have to adopt to new ways of thinking. All right. I'm sorry if this is being very firm. I'm telling you very firmly, seriously, that you have to adopt to new ways of thinking. Not just this day, today, but from now on. Next week is going to be very rigorous, students. Once calculus starts, it's going to be very rigorous. Yes, Bhavana, that's absolutely right. All right, I hope this is clear. Is this clear to everyone? Gayatri, is this clear now? All right, good. Jyoti says clear. Yes, Bhavana says yes. All right, good. All right. Now, students, that's okay. I'll go slow today, but it's very important that you understand the intention behind the classes. All right, these are not just ordinary classes. We are aiming really, really high. We are aiming IIT mains, advanced Olympiads, and Neet. All right. So calculus is going to be really, really rigorous, especially for IIT. Calculus is going to be really rigorous next week. It is going to be little lighter side on the for the NEET students. So I'll take care of that. You don't have to be so rigorous as required for IIT mains and advanced. But NEET also requires rigorous approach, but not as rigorous as required by IIT, JEE and mains and advanced, and Olympiads as well. All right. So please understand, I'm telling you firmly again that you have to adopt to new levels of thinking. All right, let's go for the next one. Tan of pi by 2 plus x. This is x, and this is pi by 2 plus x. All right. Now tan of x is this dot. This is tan of x. Tan of pi by 2 plus x is this dot. This dot. Now, if you note one thing, if I draw the cotangent here and extend this line, this is cot x. If this is cot x, and how much is this? Now, this triangle and this triangle are congruent. Let's say A, O, and B, A, C, and D are congruent. I'll draw it with the red ink. These two triangles are congruent, right? All I did is I rotated this triangle by pi by 2. I got this triangle. Now look at this. If this is cot x, this length is also same as cot x. Length is same as cot x. But because it's negative cot x. So I'll have tan of pi by 2 plus x is equal to minus cot x. That's what you said, Gayatri. That was absolutely right. Is this clear, students? Is this clear? All right, good. No, from the geometry. Students, మీరు 10th level memory తోని చేస్తే, then these 3 days are wasted. If you haven't learned the geometry of the circle, the 3 days are wasted, and you have wasted 3 days of your preparation. All right, it's clear? Good. It's clear to everyone. How about others? There are many students here, but only 6 are responding. All right, good. Veda, are you there? We are very less in number, so we should be able to focus on everyone. Veda, are you there? All right. Now I leave pi by 2 minus x to you. Let's move on to graphs. Pi by 2 minus x, try చేయండి మీరు. Let me know in the next class. All right. Try with the geometry and show the pic to me, or send that to the WhatsApp number 96422 15227, or the other number, the other WhatsApp number. All right. Now, let us plot graphs for sine and cos. I've got a circle, unit circle. Let this be x. And this is cos. This projection is cos. Now, if I have a number line, let this be 0, let this be pi by 2, let this be pi. Let's plot sine first otherwise. This is minus pi by 2, minus pi, and so on. 3 pi by 2, 2 pi, and so on. Minus 3 pi by 2, minus 2 pi. And this is my 0. Shall we plot sine or cos? Which is which is the function you are interested in, more interested in? You want me to plot sine first or cos first? All right. Cos, sine, sine, sine. Okay, majority wins. Sine is the majority. I'll go with the sine. All right, because I've already shown the projection cos here, I'll go with the cos. All right, it's the same thing. You'll see that both are same. The reason why I asked is both are same. That's why I asked you. Look at this. Cos, understand this from geometry, cos of plus x is equal to cos of minus x. Right? This projection is same as this projection. Positive angle projection, negative angle projection, both are same. So that means, and cos 0 is 1. Cos 0 is 1. What is cos minus pi by 2? 0. Cos pi by 2 is 0. You all agree with this? Now, between these two, whatever the graph or curve you get between minus pi by 2 to 0 is same as 0 to pi by 2. Why? Because this projection is same as this projection. From minus pi by 2 to 0 is same as 0 to pi by 2. So the structure from 0 to pi by 2 should be same as structure from minus pi by 2 to 0. So the structure in this part and structure in this part should be same. So structure over here and structure over here should be same. All right. Now, again, when it is somewhere here, my radius is somewhere here, when it is above pi and below pi, above pi and below pi, it is again same. So, and what is cos pi? Minus 1. Now, once I cover from 0 to 1 complete rotation, I get one complete picture of the structure of the cos function. Because this is periodic with period of 2 pi, this will repeat with, so this gets repeated like this. All right. So cos graph, whatever graph you get between this and this gets repeated till infinity. It's a periodic function. Why? Because circle is also periodic with period of 2 pi. All right. I got cos function. Now let us plot sine over here. And you will see that both are not different, but only the small difference. You'll have only very small difference between these two. And in rest all aspects, they'll be identical. And in physics, they are treated identical. Sine and cos functions are treated identical in physics. I'll tell you why. This is x. Now this is my sine. This is 0. This is pi by 2. This is pi. 3 pi by 2. minus pi by 2, minus pi, and so on. Sine 0 is 0. All right. Projection is 0. Sine pi is 0. Sine pi by 2 is 1. But now, before pi by 2 and after pi by 2. Little before pi by 2 and little after pi by 2. Or some angle before pi by 2 and same angle after pi by 2. My projection is going to be same. So it is symmetric about pi by 2. So whatever the function you have from 0 to pi by 2, you will have the same function from pi by 2 to pi. It is so is the case with 3 pi by 2. It is symmetric with respect to x is equal to 3 pi by 2. And this gets repeated. If you see cos and sine, the only difference between them is one is being shifted with respect to the other by a distance of pi by 2. If I shift this cos towards right by pi by 2, I get sine. Or if I shift this sine towards left by pi by 2, I get cos. So the only difference is the shift. Shift doesn't matter in the phenomena. Whenever you come across sine or cos in a function, in a phenomena, what you see is the characteristics of the phenomena are captured or are seen in both sine and cos. This shift doesn't matter. What kind of shift? We will deal with temporal shift in time. Time lo shift chestam manam 2 seconds later, 5 seconds later, or 1 hour later, 1 day later. How is the motion 1 minute later? Time lo shift chestam manam. Or pi seconds later, pi by 2 seconds later. So time shift chesinappudu, my structure will not change. Structure of the graph will not change. This is very important point. And in fact, you shift this cos with only little bit or sine with only a కొంచెం సైన్ ని షిఫ్ట్ చేస్తే నాకు ఈ గ్రాఫ్ వచ్చింది. All right. What is the equation of this graph? We'll talk in next class. But right now, I'm just shifting sine. If I shift sine by pi by 2 towards left, I get cos. If I shift sine towards right, I'm getting this red curve. Any shift of a sine curve is by phenomena, in phenomena, identical. అంటే ఆ ఎక్స్పెరిమెంట్ చేసినప్పుడు మనకు రిజల్ట్స్ వస్తాయి కదా, దే ఆర్ ఐడెంటికల్ ఇన్ ఆల్ రెస్పెక్ట్స్ ఎక్సెప్ట్ ద షిఫ్ట్. ఆ షిఫ్ట్ ఏంటి మనం ప్రాబ్లమ్స్ చేసినప్పుడు మాట్లాడతాం, కైనమాటిక్స్ లో మాట్లాడతాము, కైనమాటిక్స్ ఆర్ మెకానిక్స్ లో మాట్లాడతాము. బట్ ఇప్పుడు ఎనీ షిఫ్ట్ ఆఫ్ ద సైన్ కర్వ్, it could be cos or any other shift like red curve, they are called sinusoidal curves or sinusoidal functions. Sinusoidal So what is a sinusoid? Sinusoid is a curve, is either a sine curve, cos curve, or any shift of the sine or cos is a sinusoid. Is this clear, students? Funny terms, kotta terms unnai. So you please note down this term, sinusoidal functions. We'll discuss this when we talk about some kinematics or mechanics. When we come across this, we'll again talk about it. So don't worry about the new terms you're coming across. But understand that sine and cos are not two different functions. They are of the same identical structure. Their structure, their curvature, their curve, everything is identical. The only difference is the shift. So shift మాట్లాడినప్పుడే difference ఉంది దాంట్లో. కానీ షిఫ్ట్ చేసినప్పుడు మనం టైంలో షిఫ్ట్ చేస్తాం. ప్రాబ్లమ్స్ లో, ఫిజిక్స్ లో విల్ షిఫ్ట్ ఇన్ టైం. సో టైం షిఫ్ట్ చేసినప్పుడు, కోఆర్డినేట్ షిఫ్ట్ చేసినప్పుడు, that will not affect the other parameters of the phenomena. All right, few terms are new here. That's okay. Don't be scared by listening to new terms here. These terms will become clear as we come across new problems. But right now, what you have to understand is sinusoidal functions is a term for any curve which is sine, cos, or any shift of sine or cos. So any such function is called sinusoidal function. All right. So if I say I'm considering a sinusoidal function which is y is equal to cos x, ఇదేంటి cos రాస్తున్నారు మరి sinusoidal అంటున్నారు? No, sinusoidal is a term for functions which have the same structure as sine. Cos also has the same structure as sine, or any shifted form of sine has the same structure of sine. All such functions are called sinusoidal functions. Is this clear, students? Sine and cos law. Is this clear? All right. Good. Ashita says yes, sir. Gayatri says yes, sir. Bhavana, Veda, Jyoti. Please let me know if this is clear. All right. If this is clear, please let me know. I'll give you 10 seconds to respond. Okay. Jyoti says okay. All right. Good. Now let's plot. Any doubts as of now? Students, your task today is to do the complete geometry again. 10 minutes తీసుకోండి. After dinner, you sit with a book, pen and paper or pencil and paper, draw the circle, draw tangents, draw the radial line, draw the projection, and correspond everything whatever you have done yesterday, day before yesterday, yesterday and today. Today we haven't done anything new except the sine curve, sine cos curve, because you haven't done the activity. All right? Please do it. Students, కొత్త way of thinking వచ్చినప్పుడు we have to adopt to that thinking. If you don't adopt, you cannot survive in this coaching. చాలా డిఫికల్ట్ అయిపోతుంది మీకు థింకింగ్. అండ్ వన్ మోర్ థింగ్ స్టూడెంట్స్, ఫస్ట్ ఇయర్ మెకానిక్స్ ఇస్ ద మోస్ట్ ఇంపార్టెంట్ పార్ట్ ఆఫ్ హోల్ ఆఫ్ ఫిజిక్స్. మెకానిక్స్ బాగా చేస్తే మీరు ఫిజిక్స్ లో ఏ టాపిక్ అయినా బాగా చేయగలుగుతారు. బీట్ మోడర్న్ ఫిజిక్స్, ఎలక్ట్రోస్టాటిక్స్, కరెంట్ ఎలక్ట్రిసిటీ, ఎనీథింగ్, అన్నిట్లో మెకానిక్స్ వస్తుంది. థర్మోడైనమిక్స్ అన్నిట్లో మెకానిక్స్ వస్తుంది. మీరు ఏ టాపిక్ మెన్షన్ చేయండి, ఆప్టిక్స్ అంటారు కదా, ఆప్టిక్స్ లో రే ఆప్టిక్స్ అంటారు. రే ఆప్టిక్స్ లో మీరు మెకానిక్స్ రాదనుకుంటారు, బట్ మెకానిక్స్ ఇస్ హెవీలీ యూజ్డ్ ఇన్ రే ఆప్టిక్స్ ఆల్సో. మీరు ప్రీవియస్ ఇయర్ పేపర్స్ ఓపెన్ చేసి చూడండి, మీకు మెకానిక్స్ ఇన్వాల్వ్ ఉంటుంది రే ఆప్టిక్స్ లో కూడా. ఆప్టిక్స్ లో ఎలా మెకానిక్స్ వస్తుంది అని అనుకుంటారు, బట్ మెకానిక్స్ దాంట్లో కూడా వస్తుంది. కైనమాటిక్స్ వస్తుంది ఆప్టిక్స్ లో. All right, that will eventually see. That is why the first part of phase of coaching is very important. This basic mathematics, kinematics, and kinetics. These are very important for your whole of physics. నేను ఇది ఈజీ తీసుకొని నేను సెకండ్ ఇయర్ బాగా చేస్తాను, సెకండ్ ఇయర్ హెవీ వెయిటేజ్ ఉంటుంది అనుకొని సెకండ్ ఇయరే బాగా చేస్తాను, ఫస్ట్ ఇయర్ నేను మిస్ అయిపోయిందంటే సెకండ్ ఇయర్ రాదు. సెకండ్ ఇయర్ ఒక లిమిటెడ్ రేంజ్ వరకు వస్తుంది, ఎందుకంటే మెకానిక్స్ హెవీలీ యూజ్ అవుతుంది సెకండ్ ఇయర్ లో. మీకు మెకానిక్స్ రాకుంటే సెకండ్ ఇయర్ చాలా డిఫికల్ట్ అయిపోతుంది. మీకు కాన్సెప్ట్స్ వచ్చినా కూడా, మీకు ఈక్వలెంట్ రెసిస్టెన్స్ వచ్చినా కూడా, ఓమ్స్ లా వచ్చినా కూడా, అదొక్కడ మెకానిక్స్ వచ్చేసి, మెకానిక్స్ కమ్స్ ఇన్ కరెంట్ ఎలక్ట్రిసిటీ ఆల్సో. ఐఎమ్ టెలింగ్ యూ, you will get mechanics is ubiquitous in physics. Anni topics lo vastundi mechanics. You mention a topic, I'll show you a mechanics related problem in that topic. That too from previous year papers. I can guarantee that. So that's very important that this initial phase మీరు బాగా నేర్చుకోవాలి. మెకానిక్స్ బాగా వచ్చేసిందంటే, దట్ లెవెల్ ఆఫ్ థింకింగ్ వచ్చేసిందంటే, ఎనీ టాపిక్ ఇస్ బిలో మెకానిక్స్. ఆల్ రైట్, ఎనీ అదర్ టాపిక్ ఇస్ ఇన్ థింకింగ్, in new levels of thinking is their level of thinking required for new, any other topic is below mechanics level of thinking required for mechanics. All right, so mechanics is what we're going to target first. So please be very serious with mechanics. Don't take mechanics easily. And for mechanics, all these things are very important. So basic mathematics next week is going to be little rigorous, students. కొంచెం మీకు బ్రెయిన్ లో ప్రెషర్ అనిపిస్తుంది. ప్రెషర్ అంటే ఈ కొత్త థింకింగ్ కి అడాప్ట్ చేయాల్సి వస్తుంది. So once you adapt to such thinking, then you have a smooth sail. Smooth ga run avutundi mee process, mee coaching. But if you are not ready to come out of that closed thinking of school level thinking, danchi baita raakunte chala kashtam ayipotundi. See, why I'm telling all these things is because you are targeting very high. Manam ordinary MSET ala target cheyatledu. MSET definitely crack chestamu, mains kuda crack chestamu, advanced olympiads, NEET ala టార్గెట్ చేస్తున్నాం మనము. దానికోసం ఐఎమ్ బీయింగ్ వెరీ సీరియస్ అబౌట్ ఇట్. Is it clear, students? Is whatever I spoke very clear to you? All right, good. All right, good, Ashrita, good, Jyoti. Thanks for understanding. But one thing, students, so today you have to do the activity. If you don't do the activity, it's very difficult for us to continue tomorrow. It's just a 10 minutes activity, students. Just before you sleep, after dinner, sit with pen and paper, draw the circle, draw the geometry, cosecant, secant, cosecant, pi by 2, plus pi by 2, minus pi by 2. Do all those things. It's just a 10 minutes activity, I'm telling you. It will not take more than 10 minutes. All right. Whether you get it or not, you please do it. మీకు వచ్చినా రాకున్నా attempt చేయండి. Then I'll take care of it. All right. Rest I will take care. But you make an attempt. If you don't make an attempt, I cannot help you. All right. Let's go for tan. And students, we will not have so much of time to deviate from the topic and talk all such things. I'm telling you now because I want you to be serious from now onwards. Starting on a seriousness lose aithe, then coaching becomes very, very difficult for you and for us also. And we are doing this all for your good. Say this is x. Tan x is this point. So tan 0 is 0. So tan 0 is 0. Tan pi by 2. What is tan pi by 2? Can you just quickly tell me what is tan pi by 2? I go on increasing this one. When it becomes pi by 2, this line becomes parallel to the tangent line. So I don't have an intersection. So what is tan pi by 2? Excellent. Bhavna, excellent. Good. Jyoti, excellent. Gayatri, excellent. How about others? I'm asking you what is tan of pi by 2? See, there are multiple ways of thinking. We are just thinking in one direction. All right. There are multiple ways of thinking which I have to introduce you to you. All right. Good. Not defined. That's great. Now, so at pi by 2, when a function is not defined at a point, I show it with a circle like this. Pi by 2, pi minus pi by 2, minus pi. So when a function is not defined, we show it with a bubble like this on x-axis. When a function is not defined at that value is shown with a bubble on the x-axis. This is my x-axis. And this is my tan. So as x goes on from 0 to pi by 2, my tan x goes from 0 to infinity. All right. As x goes from 0 to pi by 2, my tan goes from 0 to infinity. So 0, it goes on till infinity, but as I approach pi by 2, it goes on to infinity, but it will never touch pi by 2 because at pi by 2 it's not defined. At pi by 2, there is no value of tan. So that value is I've just shown with a dotted line, that line asymptote, this is called an asymptote. Note down asymptote. Note down in the footnote లో రాసుకోండి asymptote అని. So as I go closer to pi by 2, as sir in math sir was talking yesterday, limit. As limit x tends to pi by 2 from less than pi by 2, pi by 2 minus. As x tends to pi by 2, my tan x tends to infinity. At x is equal to pi by 2, it's not defined. But below this, this is my tan function. Now, tan has a period of pi. All right, because look at this. As it goes from 0 to pi by 2, I get this fun. From pi by 2 to pi, I get negative. Again, when from pi to 3 pi by 2, I get positive. Same thing gets repeated. As you've seen, tan of pi plus x is tan x. I take this graph, take this, make a copy of it, paste it here. It goes on repeating. All right, that's a tan function. Sine and cos are very important for us in mechanics. Tan function also we'll come across in some cases. All right. So if you have got any doubts, please mention the doubts quickly. I'll try to clarify within a minute or two. Otherwise, we'll wind up. Any doubts as of now? Do you want to know pi by 2 minus x? Tan of pi by 2 minus x, what is it equal to? All right, you want to try? Good, good, Gayatri. That's absolutely good. No, that's the spirit. Excellent. All right. Good, Jyoti. Yeah, Jyoti, that's absolutely right. But I want you to show the geometry. If you can show the geometry, that would be great. That answer is absolutely right, Jyoti. But can you show the geometry? Mhm. Students, that's not a music to be learned by rote. All right, that's mathematics. So that has to be understood by logic. All right, don't just remember things in physics. You try to understand the logic behind everything you learn. All right, any other doubts you have got, students? If you want, you can unmute and speak. Is Rakshit here? Rakshit, are you there? Okay. Okay, you want to speak, Rakshit? All right. Uh, yeah, you unmute yourself. You're all right. Any doubts? Anyone?
Yes, students, you can unmute by yourself. If you have any doubts, you can unmute by yourself and speak.
Okay, all right, Rakshit. But you were not interacting, so I thought you're not there. All right, students, give me a minute and tell me what is going on in your class right now. So what is that you're studying in your class right now? The college which you're going, can you tell me what you're studying in your class right now, one by one? Can you unmute yourself and tell me what you're studying right now in class? I'll make a note of it. All right. If that is not okay, we will wind up the class here. And one more sincere suggestion is you please try to make an attempt, do the 10-minute exercise on your own. Take pen and paper tonight after dinner, before you sleep. Make an attempt and draw the geometry and try to prove all the. All right, Akshay. Friction is going on. All right, good. Okay. Okay, Rakshit says friction is going on. All right. Okay, that's okay. All right, please do the exercise. So we'll close it here. Thank you all, students. Thanks for joining. Wish you good luck and good night. Thank you, madam.
Thank you, sir. Yes, students, from next week, you have to attend classes regularly and don't leave the class in the middle of the session. 7 to 9 ante 7 to 9 కూర్చోండి and join 5 minutes before itself. Don't join at 7:38, whatever time you wish for. Okay, so please join 5 minutes before. The class timings are from 7 to 9. And from next week, please be regular. ఎప్పుడు సార్ వాళ్ళు కానీ మేడం వాళ్ళు కానీ ఏం వర్క్ ఇస్తారో ఆ వర్క్ ఆ రోజు కంప్లీట్ చేసుకోండి సో దాట్ మీకు బర్డెన్ ఉండదు ఇప్పుడు అంతా జస్ట్ క్లాసెస్ విని తర్వాత ప్రాక్టీస్ చేయొచ్చు అని పోస్ట్పోన్ చేసుకోవద్దు వర్క్ ని రైట్ యూ హ్యావ్ టు వర్క్ హార్డ్ ఈచ్ అండ్ ఎవ్రీ డే yes students if you want to crack IIT you have to work hard each and every day hope you people understand and we will meet again and we will meet again bye everyone